In this video, we'll be discussing the application of mathematics to the concept of shuffling or selection, as the case may be. So we have an example. If a committee of 7 is to be formed from 8 men and 7 women, in how many ways can this be done such that 5 men are there? This is a real life situation that occurs on a daily basis, and the analysis of the situation is that we have a total of 8 men and a total of 7 women who want to form a committee with total number of members being 7, and there's a condition that 5 men are selected to be in the committee. If that's the case, if 5 men are to be in the committee, then we're left with having 2 women to be in the committee as well, so that we have 7 members in total. And so the process of selecting 5 men to be on that committee from the total of 8 men is 8 combination 5, and then the process of selecting the remaining 2 women from the 7 women is 7 combination 2 mathematically. So multiply those 2 processes, that's 8 combination 5 times 7 combination 2, and going through the solution, we have our final answer to be 1176 ways of doing that selection. Now, that first example we just went through is a case where we're forming our committee of 7 with an exact number of men. This other example, we have an exact or a specific number of women that must be on the committee, and it's similar, so I'll just scroll through. You can pause and see the working solution. The next case now, which is quite different, is where we want to form a committee of 7 from 8 men and 7 women, such that at least 5 men are there. At least is a condition that makes 6 men to be qualified to be in that committee. 7 men, if 7 men are selected, we have at least 5 men in the committee. So we have to treat those cases individually and sum them up. The case where 5 men are there, we'll be left with a selection for 2 women, and that particular option for 5 men and 2 women is mathematically interpreted as 8 combination 5 times 7 combination 2, because we're selecting 5 men from 8 men and 2 women from the 7 available women. The second case is 6 men and 1 woman, and the last one 7 men and 0 women. You see, all the cases are always summing up to 7, which is the total number of members we want on the committee, and we sum all the cases to get our final answer, which is, of course, you can go through the workings by pausing the video, 1380. This is another case of at least, so I'll just scroll through, and the last case will be saying at most want to form a committee of 7 from 8 men and 7 women, such that at most 4 men are there. If at most 4 men are there, then 3 men could be there, 2 men could be there, 1 man could be there, or no man at all. In all these cases, we're having at most 4 men. So 4 or less, that's the interpretation. And so treat the cases exclusively. For the case of 0 man, then of course we'll have 7 women in all. That would be 8 combination 0 times 7 combination 7, right? And then we'll sum. For the case of 1 man and 6 women, that will be 8 combination 1 times 7 combination 6, right? And we do it for all the other cases: 2 men and 5 women, 3 men, 4 women, 4 men and 3 women. You see, we're able to get the other parts. The question is focused on at most 4 men, but for the women, we'll just subtract from 7. For 0 men, subtract from 7, we must have 7 women. 1 man, subtract from 7, we must have 6 women, and so on. So the sum on each case must be 7. And then for men, 8 is our n in our combination. Then for women, 7 is our n. You can see it's always 8 7 8 7 8 7 up. And then the other numbers are fixed down: 0 7, those are our r, the selections. We're selecting 0 from 8 men, 7 women from 7 women. 1 man from 8 men, 6 women from 7 women. We sum all these outcomes and it gives us the total number of possible selections, which is 5055. Thank you for watching.